Here's a problem from the 2016 AMC 8. Rectangle DEFA below is a 3x4 rectangle with DC equal to CB equal to BA equal to 1. What is the area of the bat wings shaded region? Pause the video and try to solve it yourself. Okay, let's work through it together. The bat wings seem to be two congruent obtuse triangles connected at one point, but we don't have any angle measures or side lengths, so how can we find the area? Well, look at the unshaded white triangles. It seems like we can find the area of those. Let's label them A, B, C, and D. Let's start with the congruent triangles A and B. The bases of A and B are DC and BA respectively, and the problem says they're both 1 unit long. We also know that D is equal to 4, because DC plus CB plus BA is equal to 3, and this is a 3x4 rectangle. Now, we can find the areas of triangles A and B. 1 times 4 divided by 2 is equal to 2 square units for each triangle. Now let's find the areas of C and D. We know the base lengths, but not the height, so how can we figure out the area? Well, let's take a closer look. These two angles seem to be congruent, because they're vertical angles. Now, look at these angles. DA and EF are parallel, and CF intersects them. This leads us to conclude that these two angles are congruent because of the alternate interior angles theorem. So now we know that two pairs of angles across both the triangles C and D are congruent. Using angle-angle similarity, we can conclude that both of these triangles are similar. But what's the scale factor? Well, we know that the base of the triangle C is 1, and the base of triangle D is 3. So the scale factor from C to D is 3 to 1. That means the heights of both the triangles also have a scale factor of 3 to 1. The two heights added should match the length of the rectangle, 4. 4 divided by 3 plus 1 is 1. So multiplying each of the values in the scale factor by 1 will get us the heights. The height of D is 1 times 3, or 3, and the height of C is 1 times 1, or just 1. With this info, we can calculate the area of these two similar triangles. C is equal to 1 times 1 divided by 2, or 0.5 square units, and D is equal to 3 times 3 divided by 2, or 4.5 square units. Now, we can add the areas of A, B, C, and D together to get the area of the non-shaded section in the rectangle. This is going to be 9 square units, but we're trying to find the area of the shaded section in the rectangle. The area of the 3x4 rectangle is 12 units, and to find the area of the shaded portion, we have to subtract 9 from 12. This is going to be 3, so our answer is 3 units square. Let's look at another problem where we can use a similar strategy. The figure below shows a large white circle with a number of smaller white and shaded circles in its interior. What fraction of the interior of the large white circle is shaded? Pause the video and try to figure it out yourself. Okay, let's start with the easy circles. There are 3 of these small gray circles, each with the radius of 0.5. 0.5 squared times pi is equal to 0.25 pi. So the combined area of all these 3 shaded circles is 0.75 pi square units. Now, let's take a look at the other shaded section. It seems to be a circle of radius 2, with 2 circles of radius 1 cut out of it. So how can we find the area? Similar to the last question, we can find the area of the unshaded part of the circle and subtract it from the area of the whole radius 2 circle. Each of the unshaded circles have a radius of 1. So the area is going to be 1 squared times pi, or 1 pi for each and 2 pi for both combined. The area of the whole circle with radius 2 is 2 squared times pi, or 4 pi. Subtracting 2 pi from 4 pi gets us 2 pi, which is the area of the shaded portion in the circle. Combining it with the other 3 small shaded circles, we can get a total shaded area of 2.75 pi square units. The whole big circle with radius 3 has an area of 3 squared times pi, or 9 pi square units. And because we're trying to find what fraction of that circle is shaded, we can divide 2.75 pi by 9 pi. Multiplying both sides by 4 and canceling out the pi's gets us the fraction 11 over 36, which is our answer. Thanks for watching, and if you have any questions, suggestions, or comments, please post them down below.